assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this example, we have this big door here, and it's sitting in a constant magnetic field, which is pointing into the page in my drawing. And this door is free to swing about in axis on its left side here. So we can change the flux in this door by swinging it back and forth. And what we want to know is how far will we have to rotate the door about this axis, so what angle, in order to make it so that the flux going through the door is 1/3 of its maximum value. So you can see in my drawing here, it looks like we're in the configuration where our flux will be maximized, right? Because it looks like our door is pretty much perpendicular to the magnetic field here. So if that's the case, we know the flux going through our loop here, or our door, is going to be equal to B times A times cosine of the angle between the surface normal of our door and the magnetic field. And if we're in the maximum configuration, right, we know that the cosine of theta should be equal to its maximum value, which is 1. So our flux maximum is just B times A. Which makes sense, right? Because this is just the equation for flux when we have a constant field and our area is completely perpendicular to the magnetic field, just B times A. So now, what we want to determine is what is theta when capital Phi is equal to 1/3 of the maximum. So the max over 3. So we have our expression for the maximum now, right? It's just B times A. And again, we know the magnetic flux is just BA cosine theta. So let's just plug those in on both sides. So on the left-hand side, we're just plugging in the expression for the flux in general for our door, which is just going to be B times A times the cosine of the angle between the surface normal for the door and the magnetic field. And on the right-hand side, the maximum flux is just B times A, and we're dividing that by 3. So we have a B times A on both sides here. Cancel those out. And we're just left with the cosine of theta equals 1/3. So if we take the cosine inverse of both sides of this equation, we will get that theta is just equal to the inverse cosine, or the arc cosine, of 1/3. So if you plug that into your calculator, you will get that theta should be equal to about 1.23 radians, or 70.5 degrees. So from the door initially just being closed, we would have to swing it open 70.5 degrees in order to reduce the flux to 1/3 of the value when it was just shut and maximized.